All right. Yeah. Am I audible? Am I audible? Um, am I audible? Mic testing. One, two, three. Hello. Hello. Let's see. I ran into a problem. Like there was a connectivity between my phone and my laptop, so that caused a lot of problems. I disconnected them. And yeah, I can hear me. All right. So let's get this thing started. That checks out. Yeah, we were in the middle of some intense discussions. Yeah, I use ChatGPT for that. That's my guy, David Coggins over there. Yeah, minimum spanning trees, right? That's what we were talking about. Previous years, get CSC 2025 1. Arjunzer. Here we are. Here we are. So that is 10 on 8. We solved 18 questions. That's good. So let's try to understand this one. Context-free grammar, CFG. SAB are variables, non-terminals. ABC are terminal symbols. Yes is a start variable. Okay. Which one of the following language is accepted by that grammar? Can we understand this one? This is the grammar. Start symbol as the derivation begins at as the symbol means or. So S can become either A, B or A, B, B. The structure creates a union of two distinct sets of strings. Okay. The rule is recursive. It means A can be single A or it can be A followed by another A. This process generates one or more A's. The wrong way A star. Okay, that makes sense. This is recursive. And again, similarly, the rule B generates one or more B's. The simplest string is B and it can recursively more add. Okay, combination. Combinates to form A power 2, B power n, okay, and A power n, B square. Union of both languages. By taking the union from the branches, we get the complete language generated. A power A square B power n for n greater than or equal to 1. Okay, this seems just too good to be true. We're gonna like this one. I like this one. Really, man, that seems too good to be true. But it is. It is. We are in the era of AI. Okay, that's why I wanted to study AI. So S is equals to AB and ABB. Then again, A and B are defined here. A is equals to A or AA. That's recursive definition. And again, B is equals to B or BB. Again, that's recursive definition. If you do this, B is equals to B power n for all n greater than or equal to 1. That's the definition. And a is equals to a power n. Uh, this is not for all symbol. Yeah, it is good. For all n greater than or equal to 1. So now this can be a square b power n or a power n b square. A square b power n or a power n b square. Right, that is a. And we solved it. So it seems like an easy question. That is a problem. You might think that easy question is easy. But that's not the case. Everyone solves an easy question. The real happiness is when you get a hard question that most people could not solve, but you solved it. So this is a recurrence relation. Did she answer that? No, she didn't. No, she did not answer that. It comes to, yeah, algorithms. The confusion comes from how basic is. I don't know. Can you help me with this question? Without assuming any prerequisites. Okay, I messed up the spelling of prerequisites. Master there. You were given a recurrence relation. Asymptotic growth. Explain the recurrence. Expand that. You can say it grows very fast. General expansion. 2 power k t times n minus k plus 2k n minus I to power n. When we stop, okay, if you think in recursion, general expansion. So for t of 1, it calls okay. Let's see the other methods solving. That f n is equals to other. Mm-hmm. 2 times. Alright, I need to be good at reconciliations. Okay, so what's the given expression t of n is equals to 2t n minus 1 plus n power 2 power n, and t of 0 is equals to 1 given. If you do t of 1, 2t of 0 plus 1 into 2 power 1, so that is 2 plus 2, that is 4. It is 4. And t of 2 is something like 2t1 plus n is 2, right? 2 into 2 power 2. That is 2 cube. This is 8. And this is 8. This is 16. And if you do 3 of 3, 2 times t of 2 plus 3 into 2 cube. This is 2 power 4. No, this is 2 cube 8. 8 3s are 24. Plus t of 2 is 16. This is 32. So this is 6 and this is 56. That that's good. It grows fast. So if we do the general expansion of this, what do we get? T of n. So 2t n minus 1. So this will call n minus 1 times. Oh my god. If you see t of 3, it is calling t of 2, it is calling t of 1, and it is calling t of 0. If you look at the first term, it is calling. Let's analyze the behavior. T of 1 it is calling, and t of 0 it is calling. We know it is 1, so that is 1 into 2 times. 2 times. Oh, wait. Right. It is 1 into 2, and it is 2, and it is 2. So let's have an intermediate term k and t of n minus k. So what will it do? Or you can directly do like 2 power n. It is calling n times. N times 2 power 0. That the direct thing makes sense. Plus, and what are we doing? And if you look at the second term, t of 3, so this second term is calling. N into 2 power n. Is it not? No, this is not true. When this, you will get 8 plus 3 into 2 power 24 plus 8. That's not the case. What? 2 into t of 2. Okay. Easy. Getting general form is difficult, is it not? This is a given recurrence relation. S into 2 power n, S power 2 power n minus 1. 2s power 2 power 2 power n is equals to m, which implies n is equals to log m log m. The original master theorem is not applicable. S of m. These mosquitoes. Okay. What is master theorem? And where is the original master theorem not applicable? Divide and conquer recurrences of the form Tn by b plus f of n. So a, t, n by b. It gives us some 20 pounds. 2t. Decrement recurrence. Acrobacy theorem. Okay. Master theorem is engaged into general method. This is the recurrence. 2, okay, exponential growth. What? Okay, I guess we are supposed to know recurrence relations and master theorem. Okay, so one more thing was added to our bucket list. Yeah, I will solve this recurrence relation question later. B plus tree with 5 nodes. Audience or at most 3 given is. A B plus tree is given. Okay, 3 nodes at most. 23 is now inserted. So it is supposed to go over there. It will split parent. Right. So let me tell you generally. A B plus tree actually that is. So there gotta be a connection between child nodes too. Depending upon maybe 21, 6, 12, 19 and 21. So 12 will become the new root node. So the height of the tree will increase, that is true. Okay, is it multiple correct? Yeah, you need to put this to observations. B and D. Height of the tree increases. I split at 22 up. Yeah, I mean, if you understand the functionality, it should be easy. Three-way handshaking protocol for TCP connection establishment. 3 packets. TCP header flags, okay. Right, you need to explain every technical term. Question from basics. Three-way handshake. TCP transmission control protocol. A reliable connection oriented protocol. Connection oriented. The three-way handshake. Synchronize. I want to start a connection and here is my initial sequence of number. Synchronize and acknowledge. Server replies to the packet that has acknowledge your request and here is my own sequence number. Acknowledge flag. This means acknowledge your sequence number. Now we are connected. Handshake. packets are exchanged. Hmm. So just draw the three-way handshake. Three packets are sent. Let's say this is client or machine 1, this is server, this is machine 2, packet 1, not acknowledge yet, right? And the server will send with a response. Send is equals to 1, acknowledge is equals to 1, and it will send again. This one is that, and that one is that. And then is equals to 0, is equals to 1. Okay. So this is E3. First option is wrong. Second option is correct. B and D. That's it. Yeah, that's the basics of three-way handshaking. Okay. Yeah, we should be able to solve this one. X plus ky is equals to 1, kx plus y is equals to minus 1. Linear equations, k is a real valued constant. So if you draw that one, 1k1 minus 1, this is A and this is AB, n is equals to 2. If you kind of solve it, so rank of A is equals to rank of AB is equals to 2. That is unique solution. Rank of A is equals to rank of AB is less than n. That is infinitely solution. Rank of A is not equals to rank of AB. That is no solution. So if you simplify it, R2 tends to R2 plus R1. If you do this, right, 1k1, k plus 1, 1 plus k and 0. It will be reduced like this. If k is equals to 1, I mean minus 1, then rank of A is equals to rank of AB is equals to 1. Infinite solutions. If k is not equals to minus 1, then rank of A is not equals to rank of AB. It's no solution. There exists one value of k which the above system has no solution. No, that's not true. Infinite number of values of k. This seems correct. Multiple correct. There exists exactly one value of k. Can you get exactly one solution for this one? I don't know. Infinite number of solutions. So B and D seems the correct answers. Okay. Okay, we kind of messed up this one. Determinant. Right. R2 minus KR1. This actually seems easier, does it not? That is equals to 0 and the equations are inconsistent. This is the basics of linear algebra. Okay. AD minus BC is a determinant. 1 minus k square is equals to 0. Let's say minus k square. 1 k square is equals to 1 k is equals to plus or minus 1. Alright, I don't know, like, is the video lagging? I guess the video is lagging, but I cannot do anything about it. Right, let it be. Okay. So since it was told it depends on the determinant, let's substitute in the two equations, right? 1 plus k is equals to 1 is equals to minus 1. Those are the two equations, and it will. Is that what we are doing? Now x plus ky is equals to 1, kx plus y is equals to minus 1. Those are the equations. So it will give x plus y is equals to 1 and x plus y is equals to minus 1. Nope, that doesn't work out. And parallel lines, the lines are parallel. Determinant is non-zero. Intersecting if determinant is non-zero. So if k is not equals to plus or minus 1, I mean the determinant is equal to 0 in two cases. So if this is not the case, then they will intersect. And in this case, right, x minus y is equals to 1 minus x plus y is equals to minus 1. So it will be again x minus y is equals to 1. So they are coincidental lines. That makes sense. So for k is equals to 1, no solution. K is equals to minus 1, infinite solutions. K is not equals to plus or minus 1, unique solution. That checks out. Now see, one value of k, no solution. Here's one value of k that works out. One value of k, exactly one solution. No, multiple values of k for exactly one solution. One value of k, infinite number of solutions. So that is correct. This might be a lot of analysis, but it is needed. Three variable Boolean functions when at least one of the two input variables. Two of the input variables are 1. This is a majority function. Absorption property. Dependencies. If you do AB as 1, AB, okay. Don't make it complicated. If you make AB as 1, AB as 1, it will be 1 and it is dependent on, say, if you make BC as 1, this will be 1 and right, this will be 1, 2. That's good. Just check all the possible combinations. Alright, check possibilities quickly. That's it. X of, let's do AB as 1, 1, 1. Doesn't matter, it will add H's as 1 now. This is 1, 1, so it will be 1. But RHS is dependent on D, so 1 is false. Let's do 1, 1, and it will be and 1, 1 here too. So it is entirely dependent on AB, so this is true. If you do something like BC, this is 1 and this is 1, so this is 1, 2, this is 1. That's good. And if you do like AB as 1, that is 1. This is 1. AB. No, this is false. So if you do AB as 1, the idea is this. You just need one example to prove false. But 1 is not enough to prove true. Is the video still lagging? Yeah, I guess the video is still lagging. Whatever it is. So, if you do AB, it is 1. It is 1. It is 1. That's good. And if you do AC, it is 1. It is 1. It is 1. And if you do BC, it is 1. It is 1. BC, right? See, this is 1, 2. Things are working out. Things are working out. The number minus 6 is represented as 1, 0, 1, 0 in 4-bit 2's complement form. So that will be minus 8 plus 2, that is minus 6. Yes, it is. Which of the following is 2's complement representation of minus 6? In the 8 bits, 1 triple 0, 1, 0, 1, 0. That's what I was. Okay. Can you just append those things? Sign bit extension. Sign bit extension. Okay, now everything's clicking. So if you add, doesn't matter how many ones you add here, this will be 1, 2, 4, 8, 16, 32, 64, 128. It will be minus 128 minus 64 minus 32 minus 16 minus 8 and plus 2. My bad. So this is 3, right? 6 to 8. 6, 6 and 30. 6, 2, 8, 8, 4, 12. 6, 4, 10. So it will be, what? Why is this not checking out? Oh, okay. Dude, it will become plus 8, na? Yeah, it will become plus 8. Oh, okay. And that worked, did it not? So 1, 2, 4, 8 plus 2 plus 8 plus 16 plus 32 plus 64. Dude, 1, 2, 4, 8, 16, 32, 64, 128. That is minus 128. I mean, sine bit extension is already a broad concept. So why are we working on this? 64, 32, 16. That is 10, 122 minus 6. Yes. Just a question on sine bit extension was asked out. Question 15. Which of the following statement is true for any band if history having and distinct integers? Distinct is the word that you should be checking out. The maximum length of path of the root node to any other node is n minus 1. Yes, if it is skewed BST, the in-order traversal always produces sorted sequence of elements. That is true. Finding an element takes. If it is skewed, finding an element takes so often. In the worst case, every BST is also a min heap. BST and min heap are two different things. Why? If you look at this is a BST, but this is not a min heap. 10, 15, 20. The min heap of this one will be either this. No, I mean, it will be either this or it will be either this. So this is false and this is false. This is true. This is true. AB and AB are true. AB are true. That's good. Dude, I just need to upload this, man. Hmm. The partial data path of a processor is given RARB and R32-bit registers. Okay. The same question. Is the same question printed two times? I think so, yes. Mux A can select RA and Mux B. Okay. Multiplexer can select one of these two, right? Why is option D wrong? Because something like only is given. Only is given, right? Okay, if you solve PIQ, so okay, this is lagging. Yeah, sorry about that, everybody. I have understood this question. That's good. Pay extra attention for words like only. A regular language accepted by a non-deterministic finite automata within states. Along with we need to have a few prerequisites before getting these things answered. An alphabet is a set of symbols we can use to form a string. A string is a sequence of symbols of the alphabet. A language automation. Deterministic finite automata. At each step, for each symbol, there is exactly one defined move. You are instead given under A. In each step, or at each step, for a symbol, you can have multiple possible moves around some spontaneous. Ellipse on transitions is a shared key on reading A matter. Q to organize. Every NFA can be converted into IFA subset construction. A language that can be described by a finite law. L may have NFA with fewer than Smiths. L may have accepting NFA. Okay, NFAs are not unique. L may have DFA and states where exists DFA. Subset construction guaranteed. Every DFA has greater than. Let's see. An NFA is not guaranteed to be minimal. Redundant or unreachable states can be removed to create smaller equivalent NFAs. A language may have accepting DFA with less than one state similar to the original NFA is inefficient, resulting minimal DFA can be much smaller. In this example to the left, identical to the minimal NFA, which has two states. Power set construction. My guy. Okay. So, what we learned from this is good. Something alright. NFA it stands for non-deterministic finite automata. DFA. NFA has equivalent DFA. And what is that one? Subset construction guaranteed. NFA can be redundant. So smaller NFAs are possible. That being checked out. Let's go back. Suppose in a multi-programming environment, say program segment is executed, a process goes into IMO queue and our. Okay, this is an OS question I see. A overrated operation is performed assuming that there will be a context switch whenever process requires for an IO and whenever the process returns from the IO. The number of times the process will enter the ready queue during its lifetime, not counting the time the process enters the ready queue and it is run initially. Is okay. So when you click on the run button, it will enter the ready queue that is not counted. So we are starting from here. So it will enter the ready queue once. Um, okay, we need to know something here about process scheduling. All right, this always gets my back, dude. Oh my god. So state process created and enters ready queue. The first entry is not counted. That's correct. Outer loop printf. The cycle is running. Input operation. Let's see. A process is a program in execution. If you have been a programmer word, each is a process queue that is ready to run but not currently running. The CPU only one processor at a time in a single core system. For the ready queue and ready schedule. CPU scheduling. The operating system designs each process. Ready queue. MCFS. Context switch. Whenever CPU switches from running one process to another, it must have the current program state like registers, program counter, and loads the next process state. Context switch takes time overhead because CPU isn't doing useful work during the switch. Turnaround time, the total time taken from when a process enters the system until it finishes. Completion time minus arrival time. Good. Let's say the process entered at 12 o'clock and it completed at 12:05 a.m. I mean, the processes are not that long, but just give me an example. So the turnaround time is 5 minutes. Waiting time, the total time a process spends waiting in the ready queue. Actual CPU time needed by the process. Uh-huh. Actual CPU time. Turnaround time minus burst time. Okay. So within the 5 minutes, actually CPU spent like 1 minute on that. So it is waiting for 4 minutes. That is good. Preemptive interrupted, non-preemptive CFS. The gate problem is you're visiting customer scheduling, ready queue behavior, and context switches. Process time, process arrival, they join and ready queue. Scheduler base one. It runs on the CPU. It's preemptive policy after it. Uh-huh. Ready queue like people waiting in the bank counter. CPU schedule is clearly deciding when who gets served next. A context which is like stopping with one customer, checking their paperwork and starting with another. Turnaround time is how long each customer spends from entering the bank to leaving. Waiting time is how long they just sit in the queue before being served. Wow, that's that's good. Right. So initialized the scanf. For that, you need to go to IO to scan input one. Okay. Process a transition for the C program, counting entries into ready queue. Process is running state ready queue. Okay, this is ready queue. This is running state. I see. Output loop printf the cycle continuing. If logging for printf and returning to ready 20 loops. Y input operation. The process blocks for input upon completion. It re-enters the ready queue. Ready queue entries. Okay. It waited for input and dispatch. IO request. Oh yeah. Printf is also an IO request. So requires context switch. That is just one thing that you are supposed to know. That's good. Printf. Because it is calling other function from the standard input output library. Ternary strings. Ternary. 3. Okay, consider all strings. Occurrence, at least one occurrence of consecutive symbols. Consider all as combinatorics. Not at least one occurrence of two consecutive symbols. How about we check the possible total possible combinations? That is order matters or order does not matter. 5p3 minus that does not have the occurrence of at least 2. Counting ternary strings with consecutive pairs. Calculate the total number of strings. Oh my god, you are not choosing strings with at least one pair. Why am I having a feeling like I did this question? No, like I did a question with 195 as answer. Complement. This is easier. The first symbol has three choices. The first symbol has three choices. Every subsequent symbol must be different from. Ah, okay. Okay, complement operations. No, now I got it. It is not permutation because repetition is allowed. Whenever you are given a question like um, at least one, so anything out of ABC can be chosen, and anything out of ABC. So that is 3 power 5 total combinations are possible. 27. Alright, 3 cubes. That's it. 63, 9 2s are 18. 243 possible combinations. So nowhere in the string should be a sequence of two characters, of two same characters. So that is the complement. So let's say we chose A or B or C, that is 3. And now here you can only choose either B or C, that is true. Here you can choose only A or C. Here you can only choose A or B. Similarly, if you chose B here, you can choose only A or C here. Or if you chose C here, you can only choose A or B here. Got it? So you will be only left with two choices. Anything except the previous one. So what is it? 16 times 3, that's 48. Got it? So this is complement. So 243 minus 48, that is 5, 9, 195. We got it. We got it. Wow. We got it, and we solved like what? We solved 30 questions, man. That's good. So we were given like a sort of function. The function is differentiable everywhere. Now we are coming to calculus. Yeah. The value of b must be, so limits and derivatives. Rounded off to one decimal place. Some important points: if f is differentiable, then it's continuous. Every point is continuous. A function is continuous. So both LHL, left hand limit and right hand limit, must be satisfied. F is continuous and differentiable, and x is equals to 1. Continuity. Okay, check the LHL. Check the RHL. Okay, where is she, dude? She did not answer that. See. f dash of x, it is continuous. More than one question, yeah. Okay. Continuity and differentiability. Left hand derivative. This is a basic limits and derivative question, but as you know, we fumbled up intermediate mathematics. Okay, 31 questions. We need to find a and b such that the function is differentiable at a point if its derivative exists there. Continuous at that point. Function value. Equal derivatives. So one left hand derivative is equal to right hand derivative. Okay. Okay. Continue to ensure the graph does not break. The slope of the graph is smooth. Oh wow. Oh wow. We missed everything. We missed everything. We missed everything. Huh? -2. No, what is the answer? What is the answer? I don't know. Okay, anything between -2.1 to -1.9 works. I see, I guess a range is given. Guess I will take my break, people. Should I? Yeah, we will solve this later. Bye bye.